My name is Tucker Perrin, and today I will be discussing my research on anxiety, heart rate variability, and readiness using self-collected wearable data. The dataset used in my study consists of 747 morning readiness readings through the Elite HRV app, shown there in Figure 1, using a heart rate monitor shown in Figure 2. These readings were taken daily from December 26, 2022 to present. There were 2 months, November and December of 2021, that have only 1 and 5 observations respectively. Given this limited data, these months were excluded from analysis. Each observation consists of 74 variables, 14 of which were pre-constructed by the Elite HRV app and included all objective biometrics such as heart rate variability, autonomic nervous system state, low and high frequency power, etc. 59 of the remaining variables are self-created binary variables, describing actions from the prior day or emotional state during the reading. The final variable is a brief journal entry describing the prior day. As I imagine some of the terms I throw out may be new to some, here's a breakdown of the most important biometric measures. First, the autonomic nervous system regulates an individual's involuntary functions such as heart rate, digestion, and breathing. There are 2 branches of the system, parasympathetic and sympathetic. The former is responsible for the rest and recover functions of the body, while the latter is responsible for the fight or flight responses. Activation of this branch, again, the sympathetic nervous system, has very similar symptoms to anxiety, such as increased respiratory rate and heart rate. Next, heart rate variability, or HRV, describes the variation in time in between heartbeats. Higher HRV is typically associated with better overall health, specifically cardiovascular health. This is measured in milliseconds. Finally, the LF-HF ratio is a parameter derived from analyzing the power spectrum of heart rate variability. It represents the relative activity of the low frequency and high frequency components of HRV. The LF-HF ratio is often used as an indicator of sympathovagal balance, with higher values suggesting sympathetic dominance and lower values indicating parasympathetic dominance. And since these descriptions may be difficult to grasp first time around, here's an analogy to help. Imagine HRV is a song played with many instruments. The frequency domain, see Figure 4, breaks down the song into what each instrument plays on its own. The high frequency could be the guitar and the vocals, the low frequency could be the bass and the drums. The power could be how often and loud each instrument is playing. So more bass and drums could mean more sympathetic nervous system activation. With this descriptions of the data and variables out of the way, let's address our research questions. Our primary concern is to identify any connection between self-reported anxiety and HRV. Then, assuming we do find a connection, we want to know what influences HRV. Lastly, we want to utilize the notes data to identify any linguistic trends through sentiment analysis. Before answering any of these questions, it's first important to become acquainted with the data. Figure 7 shows a Pearson correlation matrix between the built-in Elite HRV metrics. We can see some strong multicollinearity and thus decide to narrow our focus to just HRV, readiness, and LF-HF ratio. Figure 8 simply illustrates the longitudinal averages by month of HRV and readiness. Specifically, this plot illustrates the gap in data recordings from November and December of 2021. Moving on to actual findings, in Table 1, we found that there was a statistically significant difference in mean HRV, LF-HF ratio, and total power between observations classified as sympathetic and parasympathetic. Table 2 then illustrates how different self-appraisals of anxiety has a statistically significant impact on the biomarkers associated with objective anxiety. The most significant finding was that self-assessing as anxious and not excited was connected to lower HRV, higher LF-HF ratio, and lower total power than when self-assessing as anxious and excited. Essentially, we proved that objective anxiety, meaning sympathetic leaning of the ANS, and certain biometrics are statistically significantly linked. Then we found that objective anxiety can be reduced by simply reclassifying the anxiety as excitement in one's mind. To further understand the biomarkers that dictate anxiety, specifically HRV, we felt it crucial to identify the top binary tags based on correlation with HRV. We found that alcohol-related tags were among the most influential, specifically negatively influential, towards HRV and morning readiness. For example, in Figure 10, alcohol consumption of over 7 drinks had a negative correlation of 0.22, indicating a moderate negative relationship. Additionally, sitting for extended periods of time seemed to be a mild negative contributor. To conclude our analysis, All unique words with at least 10 appearances were collected with HRV, aggregated, and averaged over each appearance. We found that words related to social connection had the highest average HRV, and words connected to alcohol and work were among the lowest average HRVs. For example, in Figure 11, say-do, SAC, meet, and 254 all describe a friend, group of people, or a connection. For context, say-do is a friend of mine, SAC is the Sports Analytics Club, and 254 represents the CS 254 course. In Figure 12, we see words like paper, planning, items, which are all work-related, having among the lowest average HRV. Hungover, which is alcohol-related, additionally made the list. The comparison I found most interesting, however, was that started was the word with one of the highest average HRVs of about 69, and ended was among the lowest with about 63. While this study resulted in some pretty cool results, at least in my opinion, it is important to identify some areas of concern. First, and most obviously, is the population size of this study. It is a single case study, so our N is 1, meaning it is irresponsible to assume that these results apply to all individuals. Next, while each observation was rich with thorough data, a sample size of 747 is very small. The data, specifically the tags and notes, is also self-recorded, so it is prone to bias, subconscious dishonesty, and inconsistency. This is specifically true of the anxious and excited tags, as some days I would avoid selecting anxious because I thought claiming it would make it true or would exacerbate the symptoms. The monitor itself also has some cause for concern, as I did not take care to wash or air dry it after each use as it was instructed. And finally, these results are only showing the impact of actions on biometrics from one day to the next. It does not take into account long-term associations. For further applications of this type of research, I think it would be interesting to include the following: residence frequency breathing for competitive anxiety, daily nutrition, objective measures of social connection, and further research on self-talk and appraisal strategies. I believe these would be all important directions. These would also likely require increased planning and supervision, but would undoubtedly aid in understanding our autonomic nervous system and how it connects to anxiety. Thank you.